Okay, so today, for today we have SQL. So SQL is basically a structured query language. And it's a language, right? The same way we have HTML, CSS, JavaScript. It's a different language. It's not a front-end language per se. It's something that we usually use in the backend, right? Because we have to use a database for that. But this language is pretty much the de facto language to communicate or interact with databases. Now, SQL. First, let me try to explain how databases work. Databases that use SQL, because you will find online other database systems that are called NoSQL, right? So this is like an alternative to SQL databases. So you can find database management systems like Postgres. I think it's MySQL, IBM. I don't remember the name of that one. Microsoft SQL. There are a lot of solutions around this. And for NoSQL, there's all the solutions like MongoDB, and I think Cassandra is technically, so MongoDB, Redis, Coach. Etc., etc., etc. It's a lot of them, right? Now, the ones that we care about in this program now are SQL databases, okay? And let's see how these SQL databases work. Now, first of all, in a database, what you have are tables, okay? So you can have one or more tables, right? And by the way, usually when you start a project, you will start with one table, and then you will have two tables, and then you will have 100 tables, right? Because every time you need to add some data to your platform or your application, you probably need a way to store that data, okay? And for that, you need a table. So you will be creating a lot of tables. Every table store one type of information, right? So tables, first of all, they have names describing what the table is storing. And the other thing that tables have are columns. And every column has a name, and every column has a type of data. Okay? Now, when you have a table that, for example, is the personnel table, right? We'll make an example here. So you have the personnel. Personnel in Spanish is personal, but in English is personnel as well? Perfect. Okay, so this table, and I will draw a table here, has columns, okay? And every column every column has a type. So for example, I would say the ID, and ID for me will be numeric, and then I can have the name, and that will be a text, and then I will have let's call it last name.
You are recording the class?
Yes, I am. Yes, I am. And let's say I have another one for the social security number, also text. Okay? So you can see the table personnel will have columns, and every column will have a type, and it will have some name, right? ID, name, last name, so SSN or social security number. Now, the table can add rows. For every row, will be a data, right? The same way you have in a spreadsheet, like a Excel spreadsheet or any other type of spreadsheet, that you have columns. Usually in spreadsheets, columns are A, B, C, D, etc., and then the rows are 1, 2, 3, 4, 5. In a database table, we don't have those A, B, C, but we have columns with names, and then we have the rows. Now the rows are not numbered, right? That's one thing. So for example, here will be 1, and I say a non-number because this one is the column 1, is the value of that column, right? It's not that the row. I mean, I can have another.
Yeah, but you have one column be the unique identifier for that.
Yeah, exactly. We will learn what those are. What I'm saying is that I can have multiple columns, and this might be 1, but this might be 29. So it doesn't matter, really. There is no order in that, right? There is no order. Now, for every value in that column, I will need a value, right? So John Doe and social security number is okay. Now same for the other one. Okay, so this is the way we can store data in databases. Basically, you have tables. Every table has columns. Every column has a name and a type. And then for every row, you have to put all the values for every column, right? Now, some columns you can have. Some columns might have different properties. Like for example, you can say this column can accept empty values, like null values. That means that you don't have to put. For example, if I say the last name might be nullable, that's what we call it, nullable. If we say that the last name might be nullable, then we can also say here as null. Right? That means that we don't have that value. That's the empty value in a database. Okay? And you can have as many tables as you want. The other thing that you can do is that you can delete columns, right? You can add more columns. You can, of course, you can insert data. You can delete data. And eventually you will have a command to read data, right? You can basically say, okay, give me all the data, or you can say, give me all the data that has certain type or certain parameters, right? For example, if I add another column here, and I say, okay, this column will be a column for, I will have another column here, and this column will be for email. Well, I want something that is, no. Well, you can have email, you can have date, but something that is like more, sorry? Let's say role. Right. And then I can say, well, this person is administrator. And I can go here and say, well, this person is manager. Exactly. And I can say, okay, give me all the personnel, but then I can say, okay, give me all the personnel where the role is manager. So I'm getting all the managers, right? And then I can start making queries with different filters to get different subset of data, right? And that's actually really nice because if you think about it, there is no limit. There is no physical limit in terms of how many columns you can have, right? You can have a table with 1,000 columns if you want. And it's pretty common, by the way, for certain type of application. You can have a table with 1,000 columns. Let's say you have a table, and I'm pretty sure that big companies have this, like for example, Walmart. So Walmart probably somewhere in some Walmart data center, there is a big table that has 1,000 columns and is every transaction that goes through Walmart, right? But they have in those columns, they have what state, what city, what Walmart, right? The ID of the Walmart. What was the category of the product that they bought? What time of the day? What payment method they use? How much was it? Everything is described there. They probably even have the temperature, like the day of what was the temperature outside of the everything. Because with all that data, you can say, okay, you can start making analysis. You can start making queries where they start getting data out of that, but you're only getting data with certain parameters, and you can say, okay, this is what's happening for this product, right? And you can start seeing charts, and you can start making a lot of analysis based on that, right? I'm not saying that this is what usually a web application uses, because that's more for data analysis, like business analysis. But it's using the same concept of a table. It's just a big table with a bunch of columns with everything, every transaction is recorded. Now, for our type of applications, we use something more shorter tables in terms of how many columns. Actually, you can have tables with 20, 30 columns. That's good. You see more than that, then you need to start doing something there. And this is what you're going to start doing. You need to start making your tables more efficient. Let me explain this. Like for example, if I have a person, let's say I have a big company, or let's say this is the IRS. How do you call the person that declares the taxes? No. How do you call the person that pays taxes? No, the one that pays, yeah.
Citizen?
No, I mean, not only citizens pay taxes, but taxpayer. So taxpayer. So I have a table of taxpayers, right? Of course, I have the social security number right there. But notice something. Instead of role, I will call this. Well, let's use that citizen, or status. And instead of administrator, I would say declare, and this one is pay, right? Now, there will be more statuses, like, for example, the fair rate. I don't know, I'm just putting some weird data here. The fair, and what else? Okay, we don't know. We probably never know. Okay, but what I'm saying is that if I have 300 million records in this taxpayer table, notice that I'm putting the same words, declare, defer, late, paid, 300 million times, right? So that's not efficient, because the thing is that what happens is someone, instead of putting declare, he puts declare like this, right? Only that typo then is making these two persons different in terms of the status. Because the thing is that if I'm making a query and say, okay, give me all the taxpayers that have their taxes declared, I will probably get a lot of them, but not all of them, because this one over here, it doesn't say declare, it says declare, right? It has a typo. And then the other thing is that I'm storing too much information for every column, for this column. So what we do is that we create a different table. This time we call it statuses. right? And in this table, by the way, I will try to write it in a single. In this table, I have ID, oops, and I will have name of the status, and then for the data, I will say the status 1 is deferred. The status 2 is late. Status 3 is paid, and status 4 is, oh, that's it. So now, instead of storing text in the column for the status, I will store an integer. And that will be a number. So instead of declare, I put a 1. So now I put a 1 here, I put a 2 here, and I put a 3 here. Right? And I take this field and I will relate it to the ID of this other table. So now I'm getting tables that are not related between them, and I'm making relationships within these tables, right? And this is the part where you can make a database more efficient, right? Because now you're storing less data, right? So when you're making a query or you're retrieving information, the retrieval is faster. But the other thing is that you're making, there are ways to make this relationship in a way that if you're trying to put a 4 here, right, this will fail because there is no 4 in the statuses table. You see where I'm going? So this is making my table a little bit more efficient, because now I cannot mess it up even if I am trying to. Okay, questions about relationships? Now this relationship, there are several types of relationships that we can create, and usually you will see one of these 3 types of relationships. One is one-to-one. So a one-to-one relationship means that if you have a table here, by the way, one-to-ones are in between 2 tables. If you have a table here, A, and a table here, B, that means that every record in this table will have a record in the other table. So that's what one-to-one means. So only one record from each. So the same table, the same record here will have one matching record in the other, right? Cannot have 2. There is no way to have 2. And we will see how that works. So this is one-to-one. Now we also have one-to-many. One-to-many is the one that we saw here, right? That means that for every status, there can be many taxpayers that will have that status, right? That's what a one-to-many means, and the other one is many to many. Okay, so let me put an example of. So, I'm trying to graphic because I think it's nicer or easier to see. So here, this might be referencing this one, and this one might be
So you could
referencing.
have multiple statuses, for example, like comma deferred or something?
Sorry?
Is that because you can have like multiple statuses?
For every status, you will have multiple taxpayers with the same status, right? That's what they want to many.
Many to many.
Many to many is different. Many to many. So many to many is used for when you can have, but it's not for statuses. It's more used for relationships when. Sorry. No, relationship when you can have a combination of two main tables. Let me explain this. And I will find an example for that. So you can have a main table here. By the way, in this one, these two are main tables. Like main tables mean tables that have a lot of data, right? For example, here it might be taxpayer and 2004 2004 taxes, right? 2024. But you can have another table for 2023. That means that that person will have only one record in that 2024, right? Because you can only declare taxes once for every table. One to many, it means statuses. Like for example, you have taxpayer and status. You can have a single status, have multiple taxpayer having the same status. Many to many is when you can have multiple tables, but you need a table that combines them too, right? So let me explain this because this is the one that most complex. So you will have a record from here. You will have a record from here. And a single record here that combines them both. And this is a many to many. Let me put an example of this. I think I remember the one for Star Wars. This is, yes. Think about this.
Or you could do when it's like a marriage, when two people are married and they bring two taxes together. Would that count as many to many?
Might be. But let me put it with Star Wars, I'm not sure. Okay, no, Star Wars makes sense. It's just that I saw it on the Star Wars. There was an exercise before the program that was the Star Wars API. And when you try to model that, the only way to model, so you have a table for characters, right? Luke Skywalker, Darth Vader, Yoda, everybody there. And then you have a table for planets, right? Tatooine, Coruscant, all the other planets. And you can have a table saying, okay, who went to what planet, right? And you know that Luke Skywalker was born in Tatooine. So you have a record here that says Luke Skywalker, Tatooine. That means that Luke Skywalker was in Tatooine at some point in the movie. For example, if you didn't have Yoda any time going to Tatooine, then you will have that record. You see where I'm going? Yeah. So that's a many to many relation because a single character can go to many. So you can see it from the point of the character you have. How many planets this character went, and you can go to that table and find all the planets, or you can say how many people went to this planet, and you can go from the planet and say how many people went for that planet. So you have it two ways, right? That's a many to many relationship. But yeah, I was thinking in terms of Star Wars because I saw that before. But again, you can apply to anything that have that type of relationship. You will find it eventually, right? So if you cannot make it work with a one-to-one, and it's not like one-to-many, it's usually used for categories, right? When I say categories, it's like data or related data. Let me explain how this works, or
like transactions.
No, it's categories or related data. So let me explain categories. And let me explain how this works, by the way, because we are drawing the lines, but we don't know how these lines are connected, right? So let me explain how the lines are connected. First of all tables should have a primary key. And we will explain what a primary key is. Okay? A primary key is one column or a set of columns, it could be more than one, where the value is unique, right? So one or more columns combine where value is unique. And it's used to identify that record from the rest, right? So usually what we have in most of our databases is an ID field that we put always the first, column. We will call it ID, and it's just used for that, right? And the type of this field, we can call it field, we can call it column, is usually integer. But that was kind of like the way we think about this 5 years ago, maybe 10 years ago. Right now we use this UUID, and you've seen UUIDs before, right? Remember UUIDs? We saw it. Yeah, we talked about it in last class. It's a big number, and it's guaranteed that it's unique universally. So we make this ID UUID, right? Most databases today support this type of data, and now this is a primary key. It's essentially to identify that this record individually, right? So here, for example, if I make all my records UUID, then that means that this is not a 2021, this is 21, something, 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 something. But it's guaranteed that no two records will have the same UUID, okay? Now, that's the primary key. So all tables will have a primary key, okay? The other thing that we need to connect two tables is by using foreign keys. Now, foreign keys is, in this example, sorry? Oh, sorry. Foreign key in this example is the status, okay? So instead of status, we will call it status ID because it's a foreign key to the ID of the status table. And of course, ID is a UUID, so we know that this is one. I mean, it will never be. And now it's UUID. This was late, so 2C. Okay, so that key, that foreign key is the same. It's a column. Wait, foreign keys are columns where connecting to the primary key of another table. Now the convention is to use the other table's name underscore ID. So for example, here is status ID. Okay? And also the type will be UUID. Because it has to match the type of the key, the primary key, right? If my primary key is an integer, then my foreign key has to be an integer. But because I'm making all my primary keys as UUIDs, then my foreign key has to be a UUID. Okay? And the relationship also has two properties. And these properties are what happens when I update and what happens when I delete. When I update or delete the primary key, because remember they are related. So if these two are related, right? There is a foreign key to the ID table. What happens if I delete For example, late. What happens in the table that has the primary, the foreign key? No, there is several ways. So one is cascade. Cascade means if you delete the primary key, delete every foreign key, right? That's cascade because you're deleting, basically it's delete. That's the most dangerous. It's the one of the cleanest because it's not leaving any data behind, but it's really dangerous because when you delete, like for example, if you have, and I've seen this, some people happen this to them, it's like, if you have cascade, and then you delete the primary key, like for example, defer, right? That means that it will go to the taxpayer table and delete everything that says that is connected to defer, right? That's dangerous. That's one of the options, cascade. The other one is cascade. The other one is update. Update means if you change the key here, change the key in the other, right? That's good. And the other one is set null. Well, cascade, update, and set null. I think it's set null is basically change the value. Right? If I change the value of the primary key, don't update it there. Just go and put null because that. So basically, it's telling the database is that key that you were referring to before doesn't exist anymore, so you have to put a null there. Okay? And you have also the same for delete. So cascade, update, and set null. I think it's cascade, delete, and set null. Well, I usually put set null, by the way. I think it's the safest one. It doesn't delete data. It just set the value to null, so you know what to do after with that data, right?
And the thing is, you're keeping the same ID and
Yeah.
status, whatever it may be.
Exactly, but you don't delete the data.
Yeah, you're just changing it, so therefore it's going to change everywhere that ID is.
Remember, SQL is really old, and I think the standard is from 92. So if you think about in 92 terms, databases was really expensive, right? Storing data on a database was really expensive. So there was a lot of hacks to basically keep the minimum data possible. That's no longer the case. Data is super cheap, so you don't want to delete data, right? So the methodology is a little bit different. It's like you just want to, like for example, today, there is a command to delete data from the database. We don't actually do it we don't use it. We put a column we put a column with a date or something or a boolean saying deleted, right? And that means deleted. So when you see a company, oh, I deleted your data, they didn't. Let's just put a flag saying, oh, we delete this data. They still have your data. Because the data is the most, it's the most valuable thing. It's like, why do you want to delete that you have that data, right? They know, they know, they don't delete anything.
So, there's like laws and stuff like that right now, like access data laws. That's BS then, right?
How you prove it? Like they didn't delete it? No, it's technically, think about it.
They'll keep it safe, sure, until they hack.
Yeah, exactly. Until they hack. But no, you're right. It's like I don't think the U.S. have like a strong law against around that. I think it's more in Europe. They have laws for that. And yes, I think California has one, but they probably go around that like a loophole somewhere saying, okay, we deleted. For example, you know what they do? They mark it as deleted, and then they move it to a cold storage. So they move your records outside to a cold storage. They still have your data, but it's not online. So maybe that's the loophole. What I'm saying is that there is always ways to keep your data around.
But a company can get in trouble if that data is used for something, and you ask, hey, what is my data being used for? And
Exactly, yeah.
And they used it for something, and they find out that you used it, they can get in trouble.
Yeah, technically, yeah. Yeah, yes, of course. But the point is prove it. right?
Okay, let's just prove it, okay.
But sometimes they
And
sell
going back
it,
to the-
without, like, I'm not defending them, but sometimes they sell it without the names or whatever, it's just kind of data sets, so you don't know that.
They anonymize it. For example, that's a good practice, actually. Well, I'm not saying that it's a good practice. I'm saying that that's technically a good thing to do. It's like, oh, you deleted your data. I want to keep it around, and I know that I shouldn't because it's your data. It's private. It's identifiable to you. Okay, I anonymize the whole thing, right? But the thing is that I keep all your behavior. Your data might be protected, but your behavior is not, and that's in my database. So I don't want to lose that. Right? Cool. Okay, so this is pretty much how databases work, right? How databases are organized. You will see a lot of tables. All tables have ID. You will see a lot of tables with foreign keys, so primary key, foreign keys, and you have this type of relationships. Again, these type of relationships, what do we have in the A? When you see the arrow pointing that way, is because in one part of the arrow we have the foreign key. So here we'll have the foreign key, and in this table we have a primary key. Right? Same here. Foreign key, primary key. Right? Primary key is always the ID. Now, in this particular exercise from many to many, yeah, this is actually my bad. It's the other way around. In here, this is a primary key. This is a primary key, and these are two foreign keys: foreign key and foreign key. You see, with the for the for the Star Wars is character, okay, and then is planets. So, and this is visited. So if I have a character, let's say the character 1, and this is Luke, right? Notice that the 1 is the primary key, right? And then here in planets, I will have 4, and this will be Tatooine. And then if I want to signal or store that Luke visit Tatooine, I will have to put a record saying 1, comma 4, right? So 1 being the foreign key to characters and 4 being the foreign key to planets. And that means that Luke visit Tatooine. If I want to see, let's put another example. Who else visit Tatooine? Obi-Wan. So I have 6 is Obi-Wan. And I can have a record here saying 6 visit Tatooine. Right? Now, if I want to see all the places Obi-Wan went, right, or visited, I can say, okay, give me all the visited, filter by 6, because I only care about Obi-Wan, and let me know which planets are those. And I only have 4, right? So I know Obi-Wan visited Tatooine. Now, if I want to see all the characters that went to Tatooine, I can say, okay, in the visited table, filter by 4, that's Tatooine, and it will give me, Luke, Obi-Wan. You see, many to many. That's what many to many means. Okay? That's an example. It's just that I have it fresh in my mind. Okay, questions? A lot of questions. It's fine. Now, this is the way databases work, but we haven't talked about the language itself. Now, the language is SQL. SQL have different commands, right? And the commands, they're commands to define the data or modify or define the data, right? And here you have commands like create, so create table, create, so commands to create the tables, alter table, drop table, so be careful with that one. So drop is the drop table command, basically remove a whole table. By the way, these are commands. There is no like a, are you sure, yes or no. It's just drop table, boom, that's it. You will see, it will delete it super fast, by the way, right? So be careful with the commands that you use. Now these are the commands to define the the data: create, alter, drop, etc. Now there are commands to modify the data: insert, update, delete. Okay, so insert to add data to the tables, update to update data to the tables, and delete to delete tables. And we have commands for query, and this one is basically select. Okay, so this is one of the most used commands, because most of the time we're just selecting, right? Let me say it this way: your platform or your application is not modifying tables on the fly, right? You modify the table using some commands, probably never creating commands, you're just clicking, in the platform that we're going to use. But select is something that you will see a lot, because you need to select data to be able to show to your user. Okay? By the way, this other section here for transactions, and there is transaction, rollback. By the way, you know what a transaction is in a database? A transaction, so in a database you can have a lot of operations, but a transaction means that if one of these operations fails, everything gets reverted to the previous state, right? So you don't mess with the state of your database. So you're not adding data, and then in the fifth command you say, oh, this is not working, I have to go back and delete all that, right? You can use it as a transaction, and then you can start adding commands to that transaction, and if one of those commands fails, the whole transaction doesn't get executed. It's all or nothing, right?
It's all or nothing.
It's all or nothing.
There's nothing around the all or nothing.
No, it's all or nothing. Oh, you can, if you want to run the commands, run it individually.
Okay, that's the only way.
That's the only way.
It's all or nothing, or
It's just run individual
so it could
command.
be like you're running this transaction, something error, skip it, go to the next one, and keep on. It will all fail all those, and you have to like.
No, it's just that sometimes you want to make changes in a way that is atomic. When I say atomic, it's like, for example, if you are making a change that involves modifying several tables, you don't want to do that one by one. Because what happens if you modify one, you modify the second, and when you want to modify the third, the database fails. Now you have two tables modified, but you're missing one, so your program or your application is probably not in a good state, right? So you want to make it work in a way that all those three operations have to work, or none of them will work, right? And that's a transaction in a database. It's like all or nothing. That's what we use, right? Okay, cool. Now the commands is a new language. You can find the documentation online. Of course, we will do some commands. We will work with some commands. The most important one is select, I was saying. Now, select is the command that we use for querying data, right? Once we have all of our tables with data, we can start making queries to retrieve that data. Now, the select command, and we will practice that command today. This is what we're going to do the rest of the day. Select command has a syntax: select, then you have the fields from the table. Let's say we're going to do taxpayers, something like this, right? So this is basically saying, give me everything from the taxpayer table. This asterisk means everything. If I want to specify oh, I want the ID, and I want the name, and I want the social security number. That's another. So I can specify what fields I want. I need to specify what table I'm querying. And there's other variants here, like for example, where to filter. You can use order to order the records. So there is a lot of alternatives there. Now we're going to practice SQL today using this app, SQL Vault. Google it, and actually, let me go right now. SQL Vault is an interactive. Yes, it's an interactive tutorial to learn SQL, right? It starts with select, and you can see all the exercises here. It's like 19 lessons. From select to inserting rows, updating, creating tables, altering tables, etc., etc. So we can practice all that. Now, what I want before you go to practice SQL is that you open Supabase, because this is the database that we're going to use, right? And I want you to create an account on Supabase, and in that account, you will have a database. Remember the profiles exercise from last class? This is the table that was providing that. Now, you see that we have an ID. Let me see if I can make it bigger. ID, created at, it's a timestamp. And data, I didn't make every field, every property a field. I just make a single field with data. And notice that you can put JSON inside a column. That means that JSON is also another possible data type. So you can put integers, you can put strings, you can put UUIDs, you can put dates, booleans, and JSON, right? It's not common to see JSON in a database, but you can see it here. So, yeah. So create a project, right? If you know what project you want to build, just create it right now with the name of your project, and let's go there so we can create a table and you can see how a table works. Okay? So let's do that first. And let me stop this right here. Okay? And notice that we have all the information that we need for that table. So first thing is the name of the table. Okay? Now, you can write the name with any capitalization that you want. Now, I personally prefer all lowercase. And this is helpful because it's easier to see what is your code and what is when you're making queries and what's SQL, right? Because SQL, you can write it in uppercase, right? And you can see that the parts that are uppercase are SQL, and then the parts that are lowercase is your tables and your fields and your columns, right? That's all. But again, I prefer to put them in lowercase. Tax page. If you have words or table names with multiple names, with multiple words, you can use snake case. So, like using underscore, right? Now, description is optional. Don't pay too much attention to this, the row level security. We will learn about this later. Don't put real time. But now you have the columns, right? And you can see that initially by default we have an ID column and a created at column. And this is a good practice, right? Have a created at. That means that we're going to always store in a column when this record was added to the database, right? That's a pretty good practice. And the only thing that I'm going to change here is that the type of the ID, I want it to be UUID, right? UUID, yes. Now, if you click in that type, you see that all the types that you have in the database, you have three integer types, so int2, int4, int8. So those are 2 byte, 4 byte, and 8 byte integers. Of course, a 2 byte integer, the biggest number that you can represent is around 30K, so 32K. So 2 bits, 2 bytes. So 2 byte will give you up to, wait, 8, 16, yeah, 32. Well, you can Google it. I don't remember, but yeah, it's something around that, right? So you want to store an integer, you probably need a bigger one, right? Like int 8. Now you have the same for floats. You have a numeric type. You have JSON types. You have text and varchar. You have ID. You have date. You have time. Time with time zone. Timestamp with time zone, and Boolean. These are all the types that we have in a database. Okay? Now for the ID, I'm going to use UUID. And notice that the default value is automatically get random UUID. So it generates a random UUID automatically. So we don't have to set it. It will be generated automatically. Now for the created at, it says timestamp and the value is now. So that means that it's also automatically added. So I don't have to. And we can add more columns. So let's add columns for the name, last name, social security number, and status, right? But we don't want to add the status yet because we don't have a status table, and we want to make the connection, right? So let's add name, last name, and social security number. So name. What is the type of data that I want? Text. Default value? No. Now in here you can see that if I want to make this nullable or not, in this case, not nullable. So the user have to, or whatever using this database, have to enter a value for name. Let's go with last name. Also text. And I will leave the nullable here.
The first is nullable?
The last name should be nullable.
The name, no.
No, because I want the name, right? That's a constraint. That's what we call a constraint. That means that for a record to exist, has to have a name. Last name is not. It's optional. Now, for the social security, check this out. I will remove the use is nullable, so we have to have it. And then I will mark it as unique, right? This means that this record, this field, this column should be unique. That means that no two records will have the same social security number, of course, for obvious reasons.
Where did you?
Oh, in the gear right here. Yeah, social security number should be unique, and last name is nullable.
Name is not nullable, right?
Name is not. That means it's not optional. It's mandatory. Same as the social security. It's not nullable. It's mandatory, but it's unique also. Okay, we can save this. And we have a table taxpayers with all that data. Right? Now, in any moment, when you create a table, you can modify this table anytime. You can add more fields, you can remove fields. There are some constraints when you're adding and removing fields. For example, if you have records, right, and you try to add a new field or a new column, and you put this column is not nullable, that will fail. Because if you have data in your table, and you're making a new column that it says it cannot be nullable, what is the data? What is the initial data for all those, right? Not nullable. You cannot add a new column that is nullable. That is not nullable, right? So that's the only that's one of the problems that we have there. Now, you see that we can insert data, so I will do that. Now I don't need to put the ID. I don't need to put the created at. Let's just put the names. Oh, I forgot. Oh, the last name is optional. Yes. Oh, insert on the top.
The sequence of the social is 3, 2, and 4.
Oh, right.
Un row, ¿verdad? Insert row.
Doesn't matter.
Oh, we can edit as well.
Un row. De izquierda a derecha, un row. Abajo para arriba, un row.
There you go. Yeah, you can edit your data right there. You can double click, modify it, save it. Pretty awesome. Now I would add 2.
See, the last name is null.
Yeah, because it's nullable. Okay? We good? So you can add data to your table via the database the table editor. You can add table.
I'm sorry to know. The unique ID, the UU, how did you get that string? All that?
Oh, it's automatically generated.
Or you just save and it gives you?
Yes. Yes. Okay, so now you have a table with a primary key. Notice that the primary key ID has like a key. You see next to it is primary key, right? Created at name, last name, and social security number. Now we need another table to handle the statuses. So let's create a new table. Let's call this table statuses. I will change again the UUID here, and I will create a name. This is a text, and no. Yeah. I'm removing the created at. I don't need that for this table. Statuses with created at doesn't make sense. But it's up to you. You want to keep it or not? Yes?
Where did you get to that?
Oh, I created a new table.
You get from where?
On the left, new table.
Oh. Oh, okay.
So I give it a name, in this case, statuses. Notice the names usually plural, right? Because it's a table that has multiple records, right? Okay, so in this case, I have the ID as type UUID, generate random UUID as the default value, and then name is a text, and I remove it there, it's nullable. You know what? I should also add is unique, because it's a status, so status should be unique. Okay, save it, and I have now another table. Of course, it's 10T. Let's insert some data here. Make it unique as well, so you cannot put the same status twice. So the fair, put it late, and declare. So we have three status. Yes.
Cuando estamos creando los servicios,
Yes.
es lo mismo que lo anterior, ¿no?
Yeah, same.
Con los mismos valores prácticamente.
Well,
Yo
we have.
tengo en name,
Oh, name is text. Yeah.
name,
We only have name.
text.
And remove the is nullable and add the unique.
Es null, and
It's not nullable.
no?
So you uncheck the is nullable.
Yeah.
And you mark the one that says unique. That's it. Okay, so I created this new table. And check this out. There is a so you go to database, you should see your two tables right there, right? Well, I have four, but again, and you should have rows or records estimated for every table. You have how many columns, etc., right? Now, I want to use the schema visualizer here. You see the schema visualizer? And this will give you, don't pay too much attention to these two. You should have these two. Okay? Taxpayer and statuses. Okay? Now, there are no relationships between them because, first of all, taxpayer doesn't have a status ID. So, but I need to add that status ID and make a point to the ID of the status table. So let's do that on the table editor. I go to taxpayers. I can click here and says edit table. Or I can come back here at the end and it's a plus sign that I can also use. Right? So you can do two things. Edit table, it will show you the whole form again, right? And you can add a new column. Or you can scroll to the end of the table and there is a note to add another column there, right?
Are you recording this? Right?
Yeah, I'm recording
Let
it.
me see the property, the status.
Wait, which one?
The status.
Oh, you mean this one?
Yeah. ID. Oh, yeah.
Your ID should be a UUID.
Okay.
If you didn't create it with UUID, try to change it, and if it doesn't allow you to change it, just delete the table and create it again, right? Okay, now, on taxpayer, I want to create a new column, status ID, right here. What's the column name? Status ID. What's the type? UUID. Add foreign key, right? So I'm creating the table, I'm creating the column, but that column is of type UUID. But if I leave it like that, I will not make it connect to the other table. What I need to do is add the foreign key, and it will ask me what is the table that I want to reference. So in this case, it's the statuses, and from the status ID, I will point to ID. Now, remember the other, if the row is outdated, oh, no action, cascade and restrict, and cascade and restrict, so the following thing, no. So I will take no action here on both, and I will say this. And a low nullable, no. And that's it. Save.
Can you go?
Oh, of course. I cannot put the as nullable. I have to allow nullable. Because I already have rows. Right? I have to make it nullable. Otherwise it would not allow me to do it. Save.
You still have to put it cascade?
No, I didn't modify those values.
Okay.
How did you get the status ID field there? What did you do?
Sorry, what?
Did you create a new field, status ID?
Yeah, status ID.
You created that field?
Yeah, yeah. So there is two ways. Let me delete it again. Delete column. Okay, so there is two ways. You can click here, add the field, add the properties, or you can click here, edit table, and add it here.
Yeah.
Both ways work.
Okay. Can you call
Okay.
it status?
Yeah, I will call it status ID. Status ID. Type UUID. Why the type needs to be UUID?
It's a unique identifier, I guess, to call.
Because it has to match the primary key. The primary key is UUID, so the foreign key has to be the same type, UUID.
I'm able to make my status key. a unique-
Foreign key to the status table.
Are you getting error messages?
Foreign key?
There you go. Now, once you make a relationship, notice that if you want to modify the field, you can click and it will give you the ones that are available to select. So this one will be the fair, and this one will be the Claire. There you go.
And you're mapping it to the name or to the UID of?
The ID
Okay.
to the ID
Mapping to the ID.
to the ID. Yeah.
How do
So
you
the
do that?
status ID to the ID.
Yeah. Sorry.
The status ID, how do you get those?
The values.
Yeah.
You double click on it,
Okay.
and you will show you because it's related, right? Now it's just picking from the other table. I don't need to. Great. So now if I go to the table the schema visualizer, I will see my taxpayer is connected to statuses. Okay. This process is what we call modeling or database, right? We're creating tables and modeling how we're going to store the data, right? For every one of your projects, you will have a database with a lot of tables, hopefully not too many, probably 5, 6 tables, and you will start modeling what data, what fields do you need to store for every record in your database, right? For every record in your tables. If I'm making an app that stores, for example, what was the example that I used in the beginning, starting of the class? The one for
Star Wars.
no. We're not making a Star Wars. Like the SAS. We were talking about the SAS.
The clinical.
Yeah, clinical. Yeah. So let's say you want to store medical supply deliveries, right? You have a table for deliveries or medical supply deliveries, and then you're storing everything that you want to, every field, every column that you want to store for every delivery, right? You will have I don't know what day was the delivery, who received it, from where, what is the origin, what is the content, everything you will store it there, right? Every column will have data describing that. Okay. What's the status? It was received. It was rejected. It was, I don't know, whatever you want to store. It matches your application. Cool. Got it? Yes, question.
Quick question. Let's say you want to move Mary above John.
You don't. No, because you don't care where is the store. No, it doesn't matter because the thing is, let's query, right? You have the query editor and you say select. Remember we talked about select all from taxpayers, and that's your query. You see below is showing the results of the query. Now, if you want to order by name, now, well, John's still ahead of Mary in that sense. Let's order by SSN, as a social security number. So it depends on how you order it, by what field, right? You don't know in what order they're stored in the database. That's not relevant. The relevant is when you're querying, you want in a certain order. That's the part that you care. Now, of course, the status is there, the social security number is there. Let's say I only care about the ID and the social security number, right? I only want these two fields, right? And the status ID. Okay? Cool. Questions? Or you can ask AI. How do you ask AI? Query taxpayers. It's a query taxpayers. Showing the statuses table. That's pretty good. Yeah. I mean.
What's the code to do it? Yeah.
Oh, it has an error. Interesting. Oh, it's not that good. Statuses on taxpayer.
So
It's a little mistake, but.
So you could pull this code right here and then put it, like if you're going to use a different server, you just pull that code and put it.
Yeah, definitely. I mean, it's fair, I would say. But yeah, AI. Everybody's using AI now, so don't pay too much attention to that. Okay, so let's take a break. And again, you should take a look on Superbase. Now you have a project, right? Think about, this is the first thing that we're going to build. This is the first thing that we're going to work once we start our projects, right? So for Wednesday, what I will give you is like a methodology to decide what you want to build, right? And we will go from what's the feature, what is the visual that you want, and then what is the functionality that you want, and then at the end is the database, right? So you write all that down, and then you start from the bottom up. So the first thing that you start actually coding is your database, right? And now you know how to create your database. But by the way, you have database, you have authentication here, you have storage, all the things that you need for creating an app, right? Database, storage, application, authentic users. Storage is because in a database, you cannot store binaries, files, right? Databases are not good for that. So we need a storage service. That's all.